Today we're going to be looking at number 13, page 172, in Chemistry by Exploration, first semester General Chemistry, Spring 2016. The question reads, what is the frequency of a light source that has the wavelength of 807 nanometers? And what is the energy of this wave? So we can start off with the basic equation for a light wave, and that tells us the speed of light is equal to the wavelength times the frequency of that wave. Well, one thing we know is that the speed of light is going to be constant at 3 times 10 to the 8th meters per second. This little symbol here, lambda, tells us the wavelength of that wave, and this little symbol here, mu, tells us the frequency of that wave. Here's our basic setup for this problem. We start off with our equation for our light wave. We know that the speed of light is constant, so we can just write that down. And the wavelength is given to us at 807 nanometers. The frequency for this wave is what we're trying to find. So we can rewrite our equation so that frequency is isolated. Now, all we need to do is simply plug in the numbers. C, or the speed of light, goes on top, as our equation that we rewrote tells us. And that's 3 times 10 to the 8 meters per second. On the bottom, here we have our wavelength, which was given to us at 807 nanometers. However, we need to remember that this equation requires us to convert everything to meters. So we can write a conversion factor. That is 1 nanometer is equivalent to 1 times 10 to the negative 9 meters. And then you can simply plug that into your calculator and get your frequency for that wave. And that gives us 3.72 times 10 to the 14th hertz. And there's your answer. The second part of this question asks us, what is the energy of this wave? And the formula for the energy of a wave is energy is equal to Planck's constant. Planck's constant is a known value that is equal to 6.63 times 10 to the negative 34 joules seconds. Frequency we can get from the previous answer, and that was 3.72 times 10 to the 14th hertz. And now all we need to do is simply plug in our numbers into our equation. Energy is going to be equal to Planck's constant, which is going to be that number over here, times our frequency, which is going to be this number right there. And that gives us an answer of 2.47 times 10 to the negative 19 joules, which is the unit for energy. And there you go. That's how you solve these questions.